Welcome to Story Spectrum. Picture this. A world without lights, without phones, without almost everything you're using right now. It's hard to imagine, but for most of human history, that was reality. Our story today is about the invisible force that powers our modern world, electricity. And it all begins not with a bang, but with a spark of static. Thousands of years ago, the ancient Greeks discovered something strange. When they rubbed amber, a fossilized tree resin they called elektron, it would attract light objects like feathers. They didn't know it, but they had just stumbled upon static electricity. For centuries, this was little more than a curiosity, a parlor trick. No one could guess the giant sleeping within that tiny spark. Fast forward to the 1600s. An English scientist named William Gilbert starts experimenting seriously. He builds a device to study static electricity and even coins the term electricus. He was the first to realize that the Earth itself was a giant magnet, laying the groundwork for understanding the link between electricity and magnetism. But we were still just scratching the surface. Then the 18th century arrived and things got shocking. In 1752, Benjamin Franklin, a name we all know, decided to fly a kite in a thunderstorm. A crazy idea, right? But his goal was brilliant. To prove that lightning was a form of electricity. With a key tied to the wet kite string, he felt a spark jump to his knuckle. He proved it. This dangerous experiment showed the world that electricity wasn't just a small, man-made phenomenon. It was a powerful force of nature. This discovery ignited a firestorm of innovation. But how do you tame a lightning bolt? The challenge was to create a steady, continuous flow of electricity, not just a sudden spark. The breakthrough came in 1800 from Italian physicist Alessandro Volta. He stacked discs of copper and zinc, separated by brine-soaked cloth. This contraption, the first ever battery, produced a stable, reliable electric current. He called it the voltaic pile. For the first time, humanity had a portable, controllable source of electrical power. The age of the battery had begun, and we could finally stop rubbing amber. With a steady current, scientists could now do all sorts of new experiments. In 1820, Hans Christian Ørsted made a landmark discovery, almost by accident. During a lecture, he noticed that a compass needle deflected whenever he switched on an electric current nearby. This was the light bulb moment literally. It proved a direct link between electricity and magnetism. This phenomena, electromagnetism, is the fundamental principle behind electric motors, generators, and so much more. Inspired by Ørsted, an English scientist named Michael Faraday took the next giant leap. He was a genius, rising from a humble background to become one of history's greatest experimental physicists. In 1831, Faraday figured out that if an electric current could create a magnetic field, then a moving magnetic field should be able to create an electric current. He demonstrated this by moving a magnet inside a coil of wire, generating a flow of electricity. This is called electromagnetic induction, and he had just invented the electric generator. We finally had a way to convert mechanical motion into electrical power on a massive scale. Now we had generators to make electricity and batteries to store it. The next logical step? Putting it to work. Inventors across the globe raced to create practical applications. The first major breakthrough was communication. In the 1830s and 40s, Samuel Morse developed the telegraph. Using a simple code of dots and dashes, messages could be sent across vast distances almost instantly through electrical wires. The world suddenly felt a lot smaller. Continents were connected, news traveled at the speed of light, and the information age was born. But people wanted more than just communication. They wanted light. For centuries, nights were lit by fire, candles, and gas lamps, which were dim, smelly, and dangerous. The dream was a clean, bright, electric light. Many tried, but the real champion of this race was Thomas Edison. In 1879, after thousands of failed experiments, his team finally found a carbonized bamboo filament that could glow for over 1,200 hours without burning out. The incandescent light bulb was born. Edison was more than just an inventor. He was a visionary businessman. He knew that selling light bulbs wasn't enough. People needed a way to get electricity into their homes. So, in 1882, he launched the Pearl Street Station in Lower Manhattan, the world's first central power plant. It used steam-powered generators to supply direct current, or DC, to 85 customers, lighting up a small section of New York City. It was a monumental success. The electric age had truly dawned. But there was a problem with Edison's DC system. It couldn't travel very far without losing a lot of power, meaning you needed a power plant every couple of miles. This is where another brilliant mind enters our story. Nikola Tesla, a former employee of Edison. Tesla championed a different kind of electricity, alternating current, or AC. Tesla, a Serbian-American inventor with a flair for the dramatic, new AC had a huge advantage. Its voltage could be easily stepped up with a transformer to be sent over long distances with minimal power loss, and then stepped down again for safe use in homes and businesses. This sparked one of the greatest rivalries in scientific history, the War of the Currents. Edison, protecting his DC empire, launched a public campaign to discredit AC, claiming it was dangerous. But the practical advantages of AC were undeniable. In 1893, Tesla and his financial backer, George Westinghouse, won the contract to power the Chicago World's Fair entirely with alternating current, dazzling millions with a city of light. The ultimate victory came when they harnessed the immense power of Niagara Falls, building a hydroelectric plant that transmitted AC power to the city of Buffalo, over 20 miles away. AC had won. The system Tesla designed is the very same system that powers our grid today. The 20th century became the century of electricity. With an efficient way to generate and distribute power, innovation exploded. Electric motors, derived from Faraday's principles, began to power everything from streetcars and factory machines to household appliances like refrigerators, vacuum cleaners, and washing machines, revolutionizing industry and daily life. And then came the next great leap: electronics. In 1904, John Ambrose Fleming invented the vacuum tube, which could control and amplify electrical signals. This was the key component in early radios, televisions, and the very first computers. These computers were colossal machines, filling entire rooms and consuming vast amounts of power. But they were the start of the digital revolution. The real game-changer arrived in 1947 at Bell Labs with the invention of the transistor. This tiny, solid-state device could do everything a bulky vacuum tube could, but it was smaller, more reliable, and used far less power. The transistor made it possible to miniaturize electronics, leading to the creation of integrated circuits, microchips, and eventually the personal computer, the smartphone in your pocket, and the internet that connects us all. Today, electricity is the lifeblood of our civilization. It runs our homes, our hospitals, our economies. We generate it from a diverse mix of sources, burning fossil fuels, splitting atoms in nuclear plants, and increasingly from renewable sources like the sun, wind, and water, circling back to the very forces of nature that Franklin and Faraday first explored. We're now on the cusp of another electrical revolution. We're developing smart grids that manage power more efficiently, building electric vehicles to create cleaner transportation, and exploring new frontiers in energy storage and wireless power transfer, a dream first envisioned by Nikola Tesla over a century ago. From a simple spark on a piece of amber to the vast interconnected global network that powers our digital lives, the story of electricity is a testament to human curiosity, ingenuity, and our relentless drive to understand and harness the forces of the universe. It's a story that is far from over, with the next chapter waiting to be written by the innovators of tomorrow. Like, subscribe, and see you in another story.